What are your thoughts?
We're ready to machine.
The purpose of the IME 450 Fixture Design Lab project was to manufacture and test a CNC milling fixture which will hold the IME 144 Mill Project No. 2 family of parts during their CNC operations, utilizing Mighty Bite fixture clamps, SolidWorks, HSM Works, and the Haas CNC mill. During this project, our goal was to create a clean and simple to use fixture that would reduce operator error and allow parts to move through as quickly as possible. Importantly, our fixture passed the 7 functional requirements: locate, hold, support, to not fail under stresses, to not interfere with tool paths, to allow for part removal and cleaning, to not damage part surface. After those, the fixture was then evaluated with respect to cost, quality, productivity, and safety. We started out by designing the fixture in SolidWorks and correctly calculating and placing the features that would hold the parts and prevent them from being tossed during milling. With a part model created, CNC code was programmed so the fixture could be cut. Fixture design criteria and constraints are as follows. Fixture base size was given to us by Treon and was 0.625 by 4.5 by 8-inch Mike 6 tooling plate. The fixture must mount to Haas CNC mill table on the Haas VF2 mill. Fixture must be able to be indicated parallel to the CNC machine's axes. Fixture must be capable of producing one finished part per loading cycle. Fixture must allow CNC program to qualify datums during CNC Op 1 and locate off of datums for CNC Op 2. Fixture load and unload time must be under 1 minute. CNC blank size was given. Clamping forces must withstand the tooling forces with minimum safety factor of 2.0. And we had the Mighty Bite fixture, clamps, and rails given, as well as dowel pin sizes available for our design. Our design included one Mighty Bite fixture clamp, one dowel pin, and 1 to 2 locating rails for each part operation. The flat plate was used as our primary datum, the secondary datum was the common rail, and the pins were the tertiary datum. Adhering to DFM guidelines, clear engravings and a minimum number of components allowed for simple, rapid exchange of parts in a single, intuitive manner. Tooling force calculations. Using our largest cut and tool, the 1-inch facing mill, cutting forces were calculated and validated, and the 15 pounds force was significantly lower than the max of 900 on the VF2. To test our design, we first tested if the fixture would hold the stock correctly. After validation, we ran the observations to see that the fixture still held the part in place and no tools were damaged. Observations concluded that the fixture held the parts, no parts were damaged, and the spindle was not run straight into the mill itself. Our most important results of the fixture design include a few mistakes in the fixture itself. Since we thought the sock cut edge was on the short side of the part stock, the fixture had difficulties with stocks too thick or too thin and could only accept certain sizes. Additionally, we cut our pocket too shallow for the clamping hardware to freely spin and had to manually mill it deeper. Our ops for the parts ended up biting some of the bolt's head and made it near impossible to remove the parts, to switch ops, and cut into the 1-minute constraint. Another thing we learned was that the clamping hex would contact an adjacent wall in the fixture instead of engaging the part. We caught this and fixed this design before running blocks. We learned that precision placement of the clamping hardware and fixture design is critical to its functionality. With these bugs worked out, our fixture is an efficient design capable of doing large, hard batches with fast removal and reloading. With this project, we successfully manufactured and tested a CNC milling fixture based on an established list of constraints and criteria. Part changeover needed to be quick and the fixture should hold a high number of parts, 6. The fixture needed to have blunt edges and corners for operator safety as well as indicators for proper block alignment and loading. A revision to this design would hold the blocks on their short edge for consistency and clamping. We had a short block that was rattling around during machining. The plate's mounting holes would be more robust for fixture durability, and sharp edges and corners would have a deeper chamfer to prevent excessive operator blood loss. There were to be a bit more accurate placement of the mounting hardware and dimensioning of its surrounding features as well. We were satisfied with the end result and learned more about fixture design, CAM programming, using the CNC mill, and troubleshooting many problems that arose. We now know to quadruple check our CAM cutouts, tool selections, and proper contours.